Yes, sir.
Okay. So as I told you, today is also similar to NCS class. We'll take some more problems, which may be a little bit different from the earlier problems. So already, I hope you know the concept of using the equations and substituting in given problems. So we'll check which are the different types of problems. So in this given question, they're asking to estimate the average daily global radiation on a horizontal surface at Baroda, 22° north, that is angle latitude, 73° 10 minutes east. Okay, that is longitudinal angle. During the month of March, if the average sunshine hours per day is 9.5, assume constant A 0.28 and B 0.48. Also assume H naught itself as H naught bar. So first we need to understand this problem. So in the problem given is for a day all the values are given. So location is given for Baroda. Then they are telling for the sunshine hour per day it is 9.5, that is yes value for our reference sunshine hours for a given day. Maximum sunshine hours is not given, we need to find out. So as in the earlier cases we have told that if sunshine maximum hours are required, we can assume the complete day as a clear sun day with a complete sunshine throughout the sunrise to sunset, and we can take day length itself as a maximum sunshine hours, that is x max bar. And coming to March here, we don't know which day or which month, because estimation of average daily global radiation, if you see, average itself indicates monthly. Okay. And then daily global radiations are there. So daily means we can denote it by H. Then global by G. So Hg indicates global daily global radiation for a given day. If it is average or monthly average, we can denote it by Hg bar. And for the March month, they are asking. So as all of you know, in H naught equation, if you go for substituting values, we need the nth day. So that nth day, how to find out, that also we don't know. Or whether uh, for a given month, all the H naught values are given for taking the average, that is also not possible. So by the concept in the theory classes, I have discussed with you that a middle of the day of the given month itself can indicate the global or extraterrestrial radiations. What I mean to say is, for example, January 2020, this year, if I want to take the monthly average by measuring all 31 days with the solar measuring instruments, that average can be approximated by one of the day. For example, assume January was having all 31 days with the sunshine days without any clouds. So in such cases, one of the researcher claim suggests that you can take one of the middle day of a given month and you can approximate that itself as a average. That's why in the problem you can see you can assume H naught as H naught bar. H naught bar is the average, H naught is for the day. So which is that day? So that day is given in some of the books. So I have taken from Sukatme book here. So as per Klein, what he suggests is you can take one of the day value as H naught. You can measure that middle of the day as complete solar radiations from sunrise to sunset, and you can call it as extraterrestrial radiations or the global radiations as per your measurement. So for January, he told 17th, you can take it as one day measurement and you can claim it as average of that month. Like that, February, March, like that, all months he has given with the representing day. So for March, which day has given? 16. So here in this problem also, we'll assume March 16 is the representing the middle of that month as an average. That is H naught. Then we'll find out H naught and we'll assume H naught itself is the monthly average. Then we'll find out monthly average global radiation. The point is clear to all? Shall we proceed for further? So coming to our equations which are relating these all AB constant, H naught value, and daily global radiation average value, and sunshine hours or maximum sunshine hours. We know that by JK page equation, you can just recall the JK page equation, that is Hg bar by H naught bar can be given as or related as A plus B into bracket S by S max bar. So in this notation of the given book, they have taken a small s as small n, S max as capital N. So only that is a change. So now for H naught value to find out, I should know, see here, for H naught value, I should know solar constant, nth day, then hour angle, sine phi or the lambda, that is nothing but latitude angle, which is given in the problem, 22 degrees. Then I should know declination angle. So once we know all these unknown values in H naught, I can directly substitute and get the monthly average global radiations, Hg bar. So before going to this H naught calculation, one should calculate all these unknown values. So first by knowing the day of that year, so year is not mentioned, but March is there. So you can assume one of the day, that is March 16th, as the representing day of that average radiation or the monthly average radiation. So I'll assume March 16th and I'll find out the declination angle. So N value, if you see, they have taken 16th March, days in the February 28, and total number of days in January 31. So by substituting the 75 in the declination angle, they found out declination is to be minus 2.42 degrees. And once declination angle is known, we know the hour angle, that is cos inverse of minus tan phi tan delta. Or else what you can do is, you can list the formulas required for that problem one by one or randomly, then check which angle you can find out first or which unknown value you can find out first. So by that you can understand the procedure or the steps. So some may ask why you are going for declination first, why not hour angle first, like that. So it goes by whichever is the unknown value and which is easy for finding the first answer. So in this example, we can first find out easily the declination angle, we can find out easily. Then we can go for hour angle. So our angle phi or lambda is given 22 degrees. That is the latitude angle, north side. So I can take phi value or the lambda value as 22. Declination minus 2.42, I can substitute and I can find out our angle. So that our angle is 89.02. So all of you note down these values. Then you can find out the day length. Because this case, day length itself we can assume as maximum sunshine hours in that day, March 16th. I hope answers you are also getting same, minus 2.42 degrees for declination and omega also 89.02. Now tell me n bar how much you are getting? 2 by 15 into 89.02. That is S max bar here. You can write S max bar or day length TD or n bar can be found out by 2 by 15 into bracket cos inverse of minus tan phi tan delta. That will give us maximum sunshine hours for that March 16. 11.896. Okay. Yes, 11.86 or 87 hours is the day length. Now recall once again the H naught and how to substitute the values in the H naught formula from the earlier cases. And after substituting, you can find out the extraterrestrial radiations on March 16. So N value is known 75. Solar constant, what we are substituting is 1353 watt per meter square day for that given day. If it is for month, we are writing watt per meter square, that's all. That indicates average. So N is 75. Omega, you need to convert. So one of you can unmute and tell me why that omega is multiplied with pi by 180. And all the angles are substituted with sine phi, sine delta, phi, cos delta, and sine omega as it is. And what is the unit of this extraterrestrial radiations? H naught 11,911. And what is that unit? So for that given day, from sunrise to sunset, the extraterrestrial radiations outside the Earth atmosphere, by this correlation, the value is around 11,911. One of you can just tell me the units. What units I have to add for that value? Is it kilowatt or watt per meter square day? So as solar constant you have substitute in watt per meter square day. So 11,911 will be also be in watt per meter square day. So taking this H naught value and AB constants and sunshine hours for that given day, see here, average sunshine hours and maximum sunshine hours. If you consider, one can find out the monthly average global radiation, that is Hg bar. So as in the problem they have told H naught itself, you can assume it as H naught bar. So I'll take Hg bar by H naught bar equal to A plus B constants, S by S max bar or S bar by S max bar. In that equation, you can substitute all these values and you can find out what is the monthly average global radiations. And as per this 11,911, what I told you, watt per meter square for the average, you can write this answer in watt per meter square, not in kilojoules per meter square. It is in watt per meter square. So this is the change you have to take.
Sir, can you please go to the previous slide?
Yeah. Here, huh?
Yes, sir.
Shall we proceed?
Yes, sir.
Okay. So this value, please remember the solar constant you have written in watt per meter square day, because H naught I have not written bar. If it is written as bar, it is for month. So for a given month, I can write it as 1353 watt per meter square. For the given day, I have to write it as watt per meter square day. Here also I have to write watt per meter square day, because it is per day value. Now for the month, if you consider, as we discussed, the middle of that month, whatever the day you have considered, 15th or 16th, that represents average value or the monthly average as per the claim. So what we are doing here in the last step, we are considering this H naught value itself as from watt per meter square day to watt per meter square. Are you understanding? So once that day value is went off, now we are taking that average value. So constant A is 0.28, constant B value is 0.48, S value is 9.5, S max bar or the day length is 11.87 hours. So this hour will get cancelled here, 9.5 by 11.87, and we are getting around 0.668 as the other side constant into H naught bar you have to take. So that H naught bar we have taken 11,911 watt per meter square for the given month, and your answer will be around 7,909 watt per meter square. So that unit you need to change. This unit, whatever they have shown, this you have to change. If it is only for day, I would have written Hg equal to watt per meter square day. This problem is clear.
Yes, sir.
Okay, next one. They are just asking day length for the given location on December 1. This you can solve as our part of the earlier problem. Day length, how to find out, that is known to everyone. In the next problem, you can see. So this will take the one more problem, one more example. Find the solar altitude angle, that is alpha, at 2 hours after local solar angle or after the hour angle on June 1 for place located at 26.75 degrees north latitude. So latitude is directly written here. Also determine the sunrise and sunset hours as well as the day length. See here, what is the problem here is we can find out solar altitude by the correlations. That is not an issue. We can find out hour angle, or after 2 hours of the hour angle, we can find out. June 1st, we can find out declination angle. Then latitude is given. We'll see what relation we can use for finding the day length. Then comes to sunrise and sunset. This is the difference in the problem. So sunrise and sunsets are the new words in this problem. So here, first solving this problem, for the June 1st, we can find out declination angle, altitude angle we can find out by knowing the other angles, hour angles, altitude, latitude. So after all these findings, we can go to the day length. Now I think once you know the day length indicates the number of hours the sun has taken its rise and set or setting to the west. So between this time, the total hours represents the day length. And at the sunrise, I can consider half of the time, yes, half of the time it was on the sky before noon. And taking that into consideration, I can consider what is the sunrise time before noon and after noon, after what time it was taking place with the sunset. Okay, just keep this theme in the mind. We'll see how to solve the problem. So all of you know how to find out declination angle. I will not explain about that on June 1st. How you find out, it is left to you. So n is 152, declination angle they got 22 degrees. So as earlier also 22 degree, okay, sorry, 22 degree here it is declination angle. Earlier it was angle phi. So phi angle here it is 26.75 degrees. So if it is in minutes, you need to convert in degrees. So that should be careful. Then next is the hour angle. So hour angle they have told after 2 hours. So for each hour we know 15 degrees. For 2 hours, what may be the hour angle? It will be 2 into 15. Angle at 2 hours after the local solar angle. After 2 hours, we need to find out the hour angle, not with respect to solar local angle. Local angle from that it is 2 hours. At that point, we need to find out solar altitude. So our angle we are finding 2 times 15 degrees, 30 degrees. Then we should know this correlation, sine alpha, that is altitude, altitude angle, sine alpha. It can be related with angle phi, delta, and omega like this. Or as I told in the deriving the hour angle, we'll come across this equation also, where we are writing omega equal to cos inverse of some other words. So similarly here, if I take sine alpha, I can write it as sine phi sine delta, cos phi cos delta into cos omega. So in this equation, as you can observe here, we need angle phi and declination and hour angle. So already we have found out these values. Or write down this equation in the initial step because we need to find out altitude. Later you can find out these unknown values and substitute in the equation number 1. Like that also you can do. So phi angle is given 26.75 degrees. Delta we have found out 22 degrees. Omega at 30 degrees. So at these all points we need to find out altitude angle. Or one more method is to find the alpha, you can go by these equations. So in these equations, you can find zenith angle, cos theta z, you can find out by this relation, cos phi, cos delta, cos omega, plus same thing, sin phi, sin delta, plus cos phi, cos omega, cos delta like this. You can find the cos theta z, zenith angle minus 90 degree or 90 minus zenith angle, you will find out altitude angle. So any one of the method you can follow and find out altitude angle. So anyone can check alpha value. Is it 72.4 degrees? Also, you know how to find out the day length. So both steps you can note down and tell me whether those answers given in the book is correct or not. 72.4 degree they have told for altitude angle. Total day length hour is 10.4 hours. Ganesh, the values are correct. Others, are you following? Any replies? One of the reply at least. Shall we proceed to the next step? Abhishek,
Yes, sir.
okay. So now we know the total number of hours the sun was shining. Now just applying some rules of sunset and sunrise, we know that before 12 or in the morning session of the uh, sun path, we are using the negative sign. And for the afternoon sessions, we are using the positive sign for the sun path. Similarly, here also what they have done is morning part, what they are doing is they are taking 12 as a reference. That is a zero angle or the 12 hours. So from 12 hours, what was the sunrise time? So out of this total day length, I can divide that total day length into half, assuming that half part is the forenoon before 12 noon, another half part is the afternoon. So that why they have taken 10.4 by 2. Okay. And 12 minus that many number of hours if you take, so that exactly what I'm doing, exactly I'm dividing that time into two halves, morning and evening. So if I take 12 minus that much value, 5.2 hours, because 12 hours is the reference point. So this is coming around 6.8 hours or 6:48 a.m. So around 6:48 a.m. as per the solar or the given timings, it is having the sunrise. We are not using here local apparent time. We are not finding actual local time. Here, as per the given values, we are finding sunrise and sunset values with the standard values or the standard correlations. So sunrise is around 6:48 a.m. as per this relation. Now afternoon, if I consider, I will add next hours where it is going to sunset. At what time it is going to have the sunset. That is 12 point half of 10.4. So that is giving around 5:12 p.m. So around 5:12 p.m. the sunset is going to happen. So this is about the given problem how we are solving for sunrise and sunset. Next is zenith angle. You all can do it. We'll not go in depth for this problem because earlier problems also we have covered zenith angle relation and the declination, all other values you have covered. So anyway, today I will solve one more problem. Remaining problem, this PDF file I have uploaded in the classwork. Okay. So from that classwork PDF file, you can just go through these solved problems only. Just find out what relations they have used to solve the problems. And if any doubts are there, we can ask in the other classes or you can have some messages in the group. So that can be cleared in the group. Okay. So we'll take last problem, one of the last problem. Yes, we'll take this only. Already you have understood sunrise, sunset. we'll take the how exactly the local time should be converted. So all of you note down this problem. Find the solar altitude and azimuth angles, that is alpha angle and gamma angles, solar azimuth angles, at solar noon means at exactly 12 p.m. So exactly 12 p.m. or 00 hours. What is the solar altitude and azimuth angles on February 1? So February 1 means you have to take 31 days of January, 1 day of February. So totally it will come to 32 days. At Gainesville, USA location. So they are not okay. They have given latitude and longitude later. With this location, also find the sunrise and sunset times on that day. Take latitude phi 29.68 degrees north, longitude 82.27 degree west. Standard time longitude is 75 degrees for Gainesville. So here they are given standard time also, longitude also, means one of the relation is going to use these two values, that is the standard time of the country and the local time of that longitude. So using these two values, I can correlate with one of the equation and I can solve it for the standard sunset and sunrise time also. So using that 32 days, I can find out declination angle. Uh, we need hour angle for the altitude angle to find out. So hour angle, what they have given? 12 noon. So hour angle will be 0. There is no movement of sun from the zenith or the normal to horizontal surface. Okay. So omega we have considered 0 in this problem. Then declination angle is coming out to be minus 17.5 degrees. Then phi is given angle of latitude 29.68 degrees, that you can substitute, and one can find out the alpha angle. That is 42.8 degrees. One more method is go by zenith angle calculation cos theta z, and you can go by 90 minus zenith angle. That is also possible. Or else one more correlation they have given, 90 minus phi minus delta. That also you can just check out whether it is coming with the same answer or not. 42.8 degrees with the altitude angle. Then they are finding solar azimuth angle, that is, as per our notations, we used sine of gamma s here. Yes. Either you can go by this relation, cos of gamma s or cos of gamma s at the below here, secant alpha, or I can go by sine of gamma s using this alpha delta omega. So one, two, three relations are available as per our discussion. Or you can go by this relation also. So sine of gamma s is nothing but secant of alpha. So anyone can reply me what is secant alpha? So same equation they have used here and found out what is the solar azimuth angle for a horizontal surface. So as our angle is 0 at 12 noon, this solar azimuth angle is also 0, no value. Have understood? 62 point. For which value it is? 62.33. Alpha value you are getting 62. Okay, previous problem alpha. Previous problem alpha here, okay. Okay, sine of 26.75. Just check once again the values, okay, whether you have taken correctly. If it is 65, you will take that only. Sine of 26.75, sine 22 plus cos of 26.75 into cos 22 into cos 30. So if you have taken all these same answers values and alpha equal to sine inverse of, not cos inverse, sine inverse of this, whatever the answer you get. Is it 62.33? Chetan, after verification. Okay, 62.34 or 60.33. You take it the value. Take that value only. And for that alpha, 63.4. Sorry, 1 minute. How much you told? Yeah, 62.34. For 62.34, how much TD value you are getting, you check. Then you substitute as per the sunrise and sunset half of the times. That's why I'm asking to calculate by the calculator and tell me the answers. You can unmute and tell me in between. So according to you can find out day length and sunrise and sunset times. Because you'll find the problems in many books, but units, the solved answers, we cannot claim it is correct many times. So we need to check once again. So will you do it later? Sunrise and sunset angle as per change of alpha value. Okay. So shortly with the same procedure, we will complete this another problem and we'll wind up this topic. Later we can discuss any doubts and this whatever the change of value you told. We'll discuss about that sunrise and sunset angle of the earlier problem. Okay. So I think earlier sunset and sunrise value may change because of the alpha change of value. So coming back to this problem, we were discussing about this finding solar azimuth angle. So we know these relations, either you can go by these relations to find the gamma s value, or I can go by other relations also, 90 minus something, if you know, that also you can do. So using one of the relation, as omega value is 0, we are getting the solar azimuth angle is also 0. That means the angle made by, okay, the angle made by due south line to the inclination of the horizontal plane. So there is no inclination, 0. It is completely facing towards south only, but it is horizontal. Now we'll go back to the sunrise and sunset angle. So before that, we need to find out the hour angle. So our angle is what? Cos inverse of minus tan phi tan delta. So take tan phi tan delta values and find out the hour angle, total hour angle. So after hour angle, you find out the day length. Day length is also important for us. So we'll go by the same procedure of last problem. We'll not take different steps. We'll take the same procedure. So find the day length. Once you find out the day length, you can take half of the day length here, 5 hours, 19 minutes like this, half of the day length. So before noon, you can take 12 minus half of the day length. You can tell the morning sunrise, and 12 plus afternoon day length or half of the day length. You can tell the solar sunset time. This is as per the given values. Later we'll go by the local apparent exact as per the location given. According to that, what is the standard sunrise and sunset time? Day length you check 2 by 15 into omega, 2 by 15 into 79.65 degrees. You can remember one of the procedure or alternate procedures also. But remembering all these equations, alternate procedures will be very difficult for us. So you can make one of the standard procedure for any given problem as a reference, and that reference procedure you can keep it for your preparations for the test or exams. Anyone found out that value? Day length. Okay, half of the day length they have found out 5 hours 90 minutes. As per that, the sunrise time is 6 hours 41 minutes. Sunset time is 5 hours 19 minutes. Then later what they did is they have taken the equation of correction and other values, constants b and other things. They have found out the local apparent time. Okay, as per the local apparent time, what may be sunrise and sunset times. So they have taken the given solar time minus equation of correction minus 4 minutes correction with respect to standard time longitude and the longitude of location. See here in the problem they had mentioned what is the meaning of the standard time longitude and longitude, both they have mentioned. So we need to find out sunrise and sunset for these two times also. So that's why they are finding actual time for the given location. So that change in the location timings with 4 minutes error and equation of correction by using this correlation. So this correlation, what is the name of that correlation? Here. So this they have used. Local apparent time, standard time minus equation of correction minus 4 minutes standard time longitude minus location longitude. So why they have taken minus is because of the longitude here. West they have told, not east. So that's why they have taken minus 4 as per the west timings. And they have substituted all these values. So B value with respect to nth day 32 minus 81, they have found out constant B minus 48.46 degrees. Then they have substituted in the main equation E. So E value becoming minus 13.7 here. So we know the correlation 9.87 sine of 2B minus 7.53 cos B minus 1.5 sine B like this. So E value and this minus 4 into bracket all are in minutes. Solar time is in hours. So as per that correction, these minutes are to be added for the given location, so that they have added with the earlier time. But for India, if you see the locations, we are going to deduct the number of minutes for the local apparent time. But here in this Western cases, they have taken plus 42.75 minutes to be added. And for the sunset also, they have added 42.75 minutes. So once they add, this is the actual local time of the sunrise. That is 7 hours, 23.75 minutes. And here it is 6 hours, 1 minutes, like that, actual timings. So I think time is 4:20. We'll stop at this moment. So other problems you can refer to the PDF file what I have shared in the group and some of the notes I have shared today. So if you have any doubts and other clarifications are required, we can take some sessions or else we can discuss in the group. Okay, so that we can move further with the next syllabus. Okay, thank you.